Hello, friends. I wanted to make a quick video to update you on the status of Natalie. It's been over a month. I think it was early February when I did the last update, so this will be close to 2 months of progress for a one-person project. Not bad. I'm pretty excited about what's changed, and I wanted to go over some of those things. So we'll start at the bottom since this is reversed order. We added argv, so now you can get arguments to your Natalie program, and they come in as an array, so easy peasy. Allow objects to be frozen. So now if I have a hash like so, and I can add objects to it like this, but if I freeze it, I can no longer add an object because it's frozen. Can't modify a frozen hash. Pretty cool. We added standard in, standard out, and standard error globals, and along with that, we added IO puts and print, and the IO object stuff is all hooked up with that. So now I can do stood error dot puts hi stood error, and that actually went on the other stream, not standard out. I don't think there's much to say about that. Just mundane kind of things that you really need to have to be a programming language. Handling return from a block or proc using local jump error. This was pretty big. The way that this works in Ruby and the way we want to mimic that in Natalie is when you return from a block, you're actually raising a local jump error, which then gets caught by the enclosing method. And I'm trying to think of a way I can demonstrate that. So if I have a method with a yield, oh, and by the way, we now have multi-line expressions in the REPL, which is huge. That was not hard to implement. I don't know why I didn't do it earlier, but that's super nice. But if I do foo do return 3, why didn't that work? Okay, well, I'm not going to linger on that. That might be broken. Oh, no, that's not broken. It does exactly the same thing in Ruby. What am I trying to do here? Well, let's do it as a proc. Return 3.call. Unexpected return. Oh, right, because you can do that with a lambda. Okay, well, I might be a little bit confused about how that works. I think that we're doing it the same way as Ruby. And one of the ways that our unit tests work is we run the same unit test through Ruby and get the output. And then we run that test through Natalie and get the output and compare the two outputs. And if they're different, then that's a failure. So we're going for as much compatibility with Ruby as possible. And so whatever I did was compatible with Ruby, I'm pretty sure. The local jump error thing and using set jump and long jump was a little bit tricky. I remember that. And I can't say that it's something I fully have my brain wrapped around. Like I can understand it for a minute in order to implement it, but it's not something I use in Ruby a lot or think about in Ruby a lot, even though I might use a return from a block. It's not something I think about a lot. So anyway, I'm gonna move on, but just know that that's implemented. This was pretty big, using the C stack more instead of using a spaghetti stack, which I had talked about in one of my other videos. which is to say that we used to malloc the space for a nat environment on every stack frame, which was inefficient. Now we just allocate that on the stack, on the C stack in C, on the stack in C directly. And so it's from my very simple benchmarks, it seems an order of magnitude faster, which makes sense because we're not mallocing all those small chunks of memory all over the place. So that's pretty cool. And implementing that was a little bit challenging, but we got it done. Case when expressions, so we can now do foo when it, yeah, I don't know. This is going to be nonsensical, but why am I writing all these? Yep. So it's just a glorified if else. It's like a switch statement in C. Yeah, implementing that was pretty fun. We started working on regexes. We added regex with the Onigmo library. I have a set of videos about that if you want to look into that. That was super fun. We now return argument error and type error for bad args passed to methods. We used to just do a simple assert in C, and it used to abort the whole program. But now we raise the proper errors. We added range, so now we can do 1.100. Oops. Can I not jump to, there we go. And you can turn that into an array, and you can do this in a case when. So say case one when it's between 2 and 10, then nope. And when it's between 1 and 9, then yep. And that should, well, that should have worked. Case. Maybe I didn't actually implement that. I thought I did. Oh no, this is just broken. So I did implement that, but apparently I broke this. Okay, I'll come back to it and fix it. But we have ranges now, which is pretty cool. Let's see, allow methods to be marked as undefined. This this was kind of eye-opening for me, how Ruby does this. Define that you can't just remove a method from the table of methods on a class, because then it'll just look up the hierarchy for that method on a superclass or a module that's included. So you have to actually define the method as undefined, and that's how Ruby does it. Actually flags the method as undefined, and that's what we do. I won't get into the implementation, but we actually have a method struct that has an undefined flag on it. And so what we do is allocate the space for the method and then just flag it as undefined. And I thought that was pretty interesting that that's how that works. We started working on threads. We have p threads now. Pretty basic support. It is full of bugs, but it's a start. And learning about that was pretty fun. I started working on, we're not going to have a global interpreter lock. If I can, anything I can do about it, I'm going to do everything I can to not have a global interpreter lock like Python and CPython and Ruby MRI do. We're going to lock the data structures in the most the granular way possible so that we can avoid having a global interpreter lock. And I know that's going to make my life harder, but it's something I want to do. So I started adding locks around hashes and stuff like that, so that they should be thread safe. Like I said, still buggy, but it's a start. We added array sort, and as a part of that work, I had added the shuttle operator for strings. And Chris Watson is our first contributor, not Tim contributor, who helped me fix that because I had done it wrong, and he came along and fixed that up. So thank you, Chris, for that help. And that's exciting. Our first contribution outside of me to the language, which is just still blows me away that people are even interested in this project, and that hopefully someday we'll have more help. Added class variables. I don't use class variables that much in Ruby, but it's something that libraries use them occasionally. I've always heard that they're not thread safe. Maybe we could make them thread safe in Natalie. I'm not sure. Um, I feel like we could, and then maybe we could use them. Maybe they could be more useful than they are in Ruby. Implemented the, I don't know what you call this, or equal. Yeah, this operator that assigns a value if something is nil or false. And we added kernel nil and nil class nil. Um, and we started working on the garbage collector. I have one video about that and then another video about me crying about that because it was very hard. And I'm still working on it. It broke my threading test because threads and the garbage collector are not playing well right now together, not playing together well right now. But I'll keep working on that. So started working on the garbage collector. It's been a lot of fun. It's been challenging. It's made me question whether I should be doing this or not, as you can see from my last video. But I'm gonna keep pushing and keep learning, and yeah, that's it. So implemented next and break. Next is easy. So inside of a block, if you call next, it essentially just returns from the block. Break is very much like next, except the intention is for the program to return from the enclosing or the calling method as well as returning from the block. So return from the block and then also return from the calling function. And the way I implemented that was unique. Not the way Ruby does it. Ruby does it with a set jump and a long jump, which from my understanding and my testing is kind of slow, and I don't want to wrap every function with that. So what we do is we set a flag on the object that we're breaking with on the value. So even if it's nil, if you just call break with nothing, it's nil. Or if you're calling break with a value, we set a flag on that that says that it's a break. And then the calling function, when it's running the block, it checks the return value and checks if there's a flag. And then if so, it does a return. And we use a C macro for that. So it's not something I have to remember all over the place. So anyway, implementing break was a little bit challenging, but fun. And last, I already talked about this, but we have multi-line expressions in the REPL. So not bad for a one-man project and a little over a month or a month and a half of work in my spare time. So thanks for watching, and thanks for supporting my channel and my project. And I hope to someday say it's not mine, but it's ours. And if you're looking to contribute, please get in touch, email me, or file a GitHub issue or whatever. Love for you guys to help out, and let's make this a really great programming language. So thanks for watching.